Good evening, all students. Now we start real numbers. Yesterday we were discussing rational numbers and their decimal expansions. When a decimal number is given, we converted the given decimal number in the form of p by q. Now we continue. Yesterday's topic. Yesterday we were doing problems on do these problems. Class 10 real numbers. Real numbers, pages 10, 11, 12. Today we discuss these concepts. Number one, 15.625. It is given. We have to convert this number in the form of p by q. When a number is given, this can be written as 15.625 divided by 10 power 3. This is equal to, now we have to find the prime factors for 15,625. 15,625 5 threes 15, ones, twos, again when 3,125 is divided by 4, we get 625. Again it can be divided by 5, we get 125. And When divided by 5, we get 25. Again, 5 fives. Finally, we got this is equal to 5 power 6 divided by 2 power 3 multiplied by 5 power 3. Why? Because 10 power 3, 10 equal to 2 multiplied by 5. We can write. So, 10 power 3 equal to 2 cube multiplied by 5 cube. Therefore, this is equal to 5 cube divided by 2 cube. This is equal to, we can write 125 divided by 8. This is how we can convert the given decimal number into the form of p by q. Now we consider another problem. The second problem, 0.1255. It is given. Now we have to convert this number in p by q form. This can be written as this is equal to 1255 divided by, after decimal, how many digits are there? 0.1255. 4 digits are there. So we can write 10 power 4 in the denominator. So this is equal to, now we find the prime factors for 1255. So to find prime factors for 1255, we divide first by 5. So we get 251. 251 is a prime number. 251 is a prime number. So we can write this as 5 multiplied by 251 divided by 2 power 4 multiplied by 5 power 4. This is equal to 251 divided by 2 power 4 means 2 power 4 multiplied by 5. We can write this. Now, this is equal to 251 divided by 16 multiplied by 125 equal to 16 multiplied by 125. This is equal to 2000. 251 divided by 2000. So the given number 0.1255 is written as 1255 divided by 10 power 4, because after decimal point there are 4 digits. So we have taken 10 power 4 in the denominator. Again, in prime factorization, we got 5 multiplied by 251 equal to 1255. Here, 251 is a prime number. So we cannot simplify the prime number. Hence, we have written it as it is. 250, because 251 is a prime number. Now finally we got 0.1255, 0.1255 equal to 251 by 2000. Now we consider another problem. Third problem. This is third problem. 0.4. This can be written as 4 divided by 10. This is equal to 2 multiplied by 2 divided by 2 multiplied by 5. So this is equal to 2 by 5. This is equal to 2 by 5. And next, fourth problem, we have students can refer page number 10. This is page number 10. Do this. You can refer page number 10. Do this. Fourth problem, it is 23.34. This is equal to 2334 by 10 square. We can write. Now we find the prime factors for 2334. Now we find prime factors 2334. Two ones, 6 sevens. Again, it can be divided by 3. 3 threes, 9, 2, 6. That means 3 eights, 24, 3 nines. Again, here 389 is a prime number. 389 is a prime number. So this is equal to, we can write 2 multiplied by 3 multiplied by 389 divided by 2 square multiplied by 5 square. This is why, because 10 can be written as the product of 2 and 5. 10 square equal to 2 multiplied by 5 whole square. This is equal to 2 square multiplied by 5 square. We have written this. So the answer is, on cancellation we get 3 multiplied by 389 divided by 2 multiplied by 5 square. That equal to 3 multiplied by 389, it is 1167. 1167 divided by 5 square is 25. 25 multiplied by 2, it is 50. So finally we got 23.34. 23.34 is written as 2334 divided by 10 square. Divided by 10 square we have written so we have found the prime factors for 2334. The prime factors for 2034, 334 are 2 multiplied by 3 multiplied by 389. And 10 can be written as the product of 2 and 5. Therefore, 10 square equal to 2 multiplied by 5 whole square. That equal to 2 square multiplied by 5 square. Therefore, finally we get 3 multiplied by 2, 389 divided by 2 multiplied by 5 square, and hence the final answer is 1167 divided by 50. Now, we consider the next problem. This is the fifth problem. 1215.8. This is equal to 12158 divided by 10. This is because there is one decimal point, one digit after decimal. One digit after decimal. Therefore, we have divided this by 2. This is equal to 12158 divided by 2 multiplied by 5. So we can simply cancel by 2. So we get 1000. 6079 divided by 5. So this is how we converted the decimal numbers in the form of P by Q. Now, theorem 1.3. Now, theorem 1.3 statement, we write the statement of theorem. Theorem 1.3. Let x be a rational number. Let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form of P by Q where where P and Q are co-prime co-prime and prime factorization the prime factorization and the prime factorization of Q is of the form is of the form is of the form 2 power n 5 power m, where n m are non-negative integers. Non-negative integers. So let us consider the problems which we have discussed earlier. Now in this term, what is the statement? X is a rational number in expressed as a decimal number which terminates. So in the above example, this is 1215.8. It is a rational number. 1215.8 is a rational number, and this number can be expressed in P by Q form. It can be expressed in P by Q form, and the denominator can be is of the form here we have 5. Here we have 5. 5 is of the form 2 power n. 5 is of the form 2 power n multiplied by 5 power m. Five can be written as the denominator 5. 5 can be written as 5 equal to 2 power 0, 5 power 1. So that means this is of the form 2 power n, 5 power m. So this is the statement of the theorem. That means the denominator of the denominator can be expressed in the form of 2 power n, 5 power m. And PQ are co-primes. If you observe these two numbers, 6079 and 5. Okay, I will write here. This one, the first example is 15.265. This is equal to The first problem is it is 125 by 8. It is 125 by 8. This is first example. And the second problem is we have the second problem 0.1255. 0.1255 equal to, so here if you observe this 251 by 2 power 4 multiplied by 5 power 3. So the denominator is of the form 2 power n multiplied by 5 power m. Denominator is of the form 2 power n multiplied by 5 power m. It is of the form 2 power n multiplied by 5 power m. And 251 divided by 2000, these two numbers are prime numbers or co-prime numbers in this example 2 problem. And 0.4, it can be expressed as 2 by 5. Again, in this, the denominator 5 equal to 2 power 0, 5 power 1. Denominator can be expressed as 2 power 0, 5 power 1. 2 power 0 is nothing but 1. So the denominator can be expressed as 5 multiplied by 1. So 2 power 0 multiplied by 5 power 1. And next in this fourth problem, in this fourth problem also, the denominator is of the form, this is denominator is 2 multiplied by 5 square. This is of the form 2 power n multiplied by 5 power m. And 1167 and 50 are co-primes. These two are co-primes. And next problem is 1215.8. Here also 6079 by 5. 6079 and 5 are co-primes, and the denominator 5 can be expressed as 2 power 0, 5 power 1. Therefore, it is of the form 2 power n multiplied by 5 power m. So this is the meaning of the statement of the theorem. Now we consider some problems. The first one is 25 by 2. This is equal to, here in the denominator 2 is there. So by which number it should be multiplied to get 10? So it should be multiplied by 5. So 25 multiplied by 5 divided by 2 multiplied by 5. So there will be no change if you divide and multiply by 5. 5 by 5 equal to 1. So this is to get the form 10 in the denominator. This is equal to 125 divided by 10. This is equal to 12.5. So this is the first problem. That is when the denominator is of the form 2 power n 5 power m, when denominator value is of the form 2 power n 5 power m, we can convert this into the decimal form which terminates. That is, it can be expressed as a terminating decimal number. Now we consider another example, 26 by 25. This is equal to 25. 25 equal to 5 square. So 5 square is there. So if we multiply, we want to get the form 10 square. So 5 square must be multiplied by 2 square. So 26 multiplied by 2 square divided by 5 square multiplied by 2 square. Why should we multiply and divide by 2 square? Because in the denominator we should get the form 10 square. So 26 multiplied by 4. 26 multiplied by 4 is 104 divided by 10 square. This is equal to 1.04. 1.04. That is, again, I would like to explain this. Twenty-six by 25. 26 by 25. 25 should be multiplied by 4 to get 100. To get 100, which can be expressed in the form of 10 square. So we multiplied and divided by 2 square. We multiplied by 2 square and divided by 2 square. So we got 10 square in the denominator. We got 10 square in the denominator. Finally, we have converted 26 by 25 into a decimal number which terminates and it is 1.04. Now we consider another problem to understand the concept 3 by 8. The third one is 3 by 8. This is equal to 3 by 8 can be written as 2 power 3. Now we want to get 10 cube. 10 cube in denominator because 2 power 3 is there. So 2 power 3 multiplied by 5 power 3. So we should divide by 5 power 3 both in the numerator and in the denominator. That is 3 multiplied by 5 cube by 2 power 3 multiplied by 5 power 3. You must understand this concept very carefully. Why should we multiply by 5 power 3 only? Why should we multiply by 5 power 3 only? Here we want to get the denominator 10 cube. To get 10 cube in the denominator, we have multiplied and divided by 5 cube. We have multiplied and divided by 5 cube. So 3 multiplied by, what is the value of 5 cube? It is 125. 125 divided by 2 power 3 multiplied by 5 power 3, that is 10 power 3. This is equal to 125 . 125 multiplied by 3 equal to 375. This is equal to 375 divided by 10. It is 1000. It is 1000. So this can be written as 0.375. 0.375. The given number 3 by 8 is converted into a decimal number 0.375. To convert this, what we have done is 8 can be expressed as 2 power 3. Denominator should be in the form of 10 power 3. To get 10 power 3, 2 power 3 must be multiplied by 5 power 3. So, in the next step, we have multiplied and divided by 5 power 3. This is a very important step by which number it should be divided and multiplied. By 5 power 3, we should multiply and divide. What is the reason? To get the form 10 power 3 in the denominator. Why 10 power 3 only? Because 2 power 3 is there in the denominator. If 2 power 8 is there in the denominator, by which number you should multiply and divide? By 5 power 8 to get the form 10 power 8. So students must understand this concept very carefully. And now we consider another problem. Now the fourth problem. 7 by 8. 7 by 8. We must convert 7 by 8. 7 by 80. 7 by 80. Now you can refer to page number 10. These are the problem textbook only. 7 by 8. Now we find prime factors for 80. So 2 40s, 2 20s, 2 10s, 2 5s. This is equal to 7 by 2 power 4 multiplied by 5. This is equal to. Now my question is, there is 2 power 4 is there and 5 is also there in the denominator. By which number we must multiply? Now, if you observe this, I want to get the form 10 power 4 in the denominator. So 2 power 4 is there and 5 is also there. It should be multiplied by 5 power 3. Then only you get the form 2 power 4 multiplied by 5 power 4. 10 power 4. To get the form 10 power 4 in the denominator, we have already 2 power 4 multiplied by 5 in the denominator. Now by which number it should be divided and multiplied? So now in the next step, I write 7 divided by 2 power 4 multiplied by 5 multiplied by, I write it in a red color, 5 power 3, 5 power 3. Why we have multiplied and divided by 5 power 3 only? Because if we multiply and divide by 5 power 3, then we get the denominator in the form of 10 power 4. We get 10 power 4 in the denominator. So, this is equal to 7 multiplied by 125. 7 multiplied by 125 divided by, in the denominator denominator you will get form 2 power 4 multiplied by 10 power 4. This is equal to 7 multiplied by 125. It is 875. 875 divided by 10 power 4. 10 power 4. That equal to 0.0875. This is how we converted the given number 7 by 80 into the decimal form 0.0875. Now I would like to explain this again. 7 by 80. We have 7 by 80. I have written 80. I have found prime factors for 80. Prime factors for 80 are 2 power 4 multiplied by 5. So I have found the prime factors. Now 5 is in the denominator. 2 power 4 multiplied by 5 is in the denominator. I want to get the form 10 power 4 in the denominator. To get 10 power 4 in the denominator, I should multiply by 5 power 3. Why should I multiply by 5 power 3 only? Because in the denominator we have already 2 power 4 multiplied by 5. So I want to get 5 power 4. So if I want to get 5 power 4, 5 must be multiplied by 5 power 3. 5 must be multiplied by 5 power 3. So this is the reason I multiplied the denominator and numerator by 5 power 3. So you just observe this. I divided and multiplied the both numerator and denominator by 5 power 3. So then I got the form 2 power 4 multiplied by 5 power 4. 2 power 4 multiplied by 5 power 4. This is 5 power 4. So 2 power 4 multiplied by 5 power 4, it is 10 power 4. So I got the form 10 power 4 in the denominator. Therefore, 875 by 10 power 4 equal to 0.0875. From all these examples, what we can conclude is now we give a statement, a theorem 1.4. Theorem 1.4. First, we are considering some examples, and after considering examples by observation, we are trying to understand the mathematical statement and the statement of the theorems. Let x equal to p by q be a rational number, be a rational number such that the prime factorization of q q means the denominator of q is of the form is of the form 2 power n 5 power m, where n and m are non-negative integers or non-negative integers. Then x has a decimal expansion which terminates. So we have already considered several examples to understand this. A number x is given in p by q form. When a number can be expressed in p by q form, it is a rational number. Now, the prime factorization of the denominator, that is q, is of the form 2 power n 5 power m. In the previous examples, we considered the denominators, and we have found that they are the denominators of those numbers are of the form 2 power n 5 power m. Then such rational numbers can be expressed in a decimal expansion form. That is, they can be expressed as terminating decimal numbers. Now, we consider some other problems. This is do these problems. Page number 11. Do this. In the form of p by q, where q is of the form 2 power n 5 power m, where n and m are non-negative integers, non-negative integers or non-negative integers, and then write write, and then write, and then write the numbers, the numbers, the numbers in their decimal form. Decimal form. So let us see this. Write the following rational numbers in the form of p by q. That is, a number in the form of p by q is given to you, and q is of the form. Q is of the form means the denominator is of the form this is 2 power n multiplied by 5 power m. Denominator is of the form 2 power n multiplied by 5 power m, where n and m are non-negative integers. Then write the numbers in their decimal form. We have already done some problems in this mode. Now we solve the problems. The first problem, 3 by 4. This is equal to 3 by 2 square. So denominator is of the form 2 square is of the form 2 square multiplied by 5 power 0. Here n equal to 2, m equal to 0, because we compare this with 2 power n 5 power m. 2 power n 5 power m. So by which number we should multiply and multiply both numerator and denominator? We must multiply. So this is equal to 3 by 2 square. We must multiply and divide by 5 square. Why should we multiply and divide by 5 square? Because we want to get 10 square in the denominator. To get 10 square in the denominator, we must multiply and divide by 5 square. If you multiply the denominator by 5 square, you get the form 10 square. So this is equal to 3 multiplied by 25 divided by 10 square equal to 75 by 10 square equal to 0.75. So remember, we are following mathematical procedures. We should not simply divide by 4 and we should say, yes, it is 0.75. This is not the procedure in class 10 mathematics. We should consider the denominator, and we must say that it is of the form, it is denominator is 2 square. When denominator is 2 square, we can say that this is of the form 2 square multiplied by 5 power 0. So we should compare this denominator with the formula 2 power n multiplied by 5 power m here, to n equal to 2 and m equal to 0. This is the procedure. The answer should be by following the mathematical procedure. We should follow strictly the mathematical procedure in accordance with the syllabus. We know the answer 3 by 4 equal to 0.75. We can directly write the answer. But In class 10 mathematics syllabus in real numbers, we should write the answer in this following this procedure only. We have a theorem. So now we consider another problem. Second problem. 7 by 25. This is equal to 7 by 5 square. Now I consider the denominator 5 square. Denominator is of the form 2 power 0 5 square. So 5 square can be written as 2 power 0 5 square. Here we compare this with the formula 2 power n 5 power m formula, n equal to 0, m equal to 2. So this must be multiplied and divided by 2 square. So we want to get 10 square in the denominator. We want to get 10 square in the denominator. So it must be multiplied and divided by 2 square. So we have already 2 square and it should be multiplied by 2 square. Therefore, we write this step 7 by 5 square multiplied by 2 square divided by 2 square. Why should we do this? Why we multiplied and divided by 2 square? This is because we want to get 10 square in the denominator. 5 square can be expressed as 2 power 0, 5 power 2, and it is in the form 2 power n 5 power m formula. This is equal to 7 multiplied by 4 divided by 10 square. This is equal to 28 by 10 square equal to 0.28. 0.28. We know the answer. It is 7 by 25. Simply we can give the answer directly. But for each and every step, we must give the reason. Why should we do this step? Why should we multiply and divide by 2 square? Why should we convert this? Because here we have a theorem and we have already studied the statement of the theorems, theorem 1.3 and theorem 1.4. We have theorem 1.3 and theorem 1.4. So we must apply these theorems in solving these problems. Simply giving the answer is not important. We must give the reason and we must follow the statements of the theorems. And next problem. Third problem is 51 by 64. Now we find prime factors for 64. 64 to 32s to 16s to 8s to 4s to 2s. So 64 is equal to 1, 2, 3, 4, 5, 6. 2 power 6. So this can be written as 2 power 6 multiplied by 5 power 0. Now we compare this with a 2 power n 5 power m formula. Here n equal to 6, m equal to 0. So to get 10 power 6 in the denominator, to get 10 power 6 in the denominator, 2 power 6 must be multiplied by 5 power 6. So this is equal to 51 divided by 2 power 6 equal to 51 divided by 2 power 6 multiplied by 5 power 6 divided by 5 power 6. So you must understand why we have divided and multiplied by 5 power 6. This is to get 10 power 6 in the denominator. This is to get 10 power 6. So here we have compared the denominator q equal to denominator q. Q equal to 2 power n 5 power m. 2 power n 5 power m. Here n equal to 6, m equal to 0. So now we have to multiply. This is equal to 51 multiplied by 5 power 6 divided by 10 power 6. This is equal to 51 multiplied by 5 power 6, it is 15,625 divided by 10 power 6. This is equal to 796,875 by 10 power 6. So this is equal to 0.796875. This is the answer. We should strictly follow the theorems. So this is the answer. Theorem 1.3 and 1.4 should be applied to solve these problems. Without understanding the statements of theorems 1.3 and 1.4, we cannot answer to these questions. 51 by 64, 64, we have found prime factors for 64. We have found prime factors for 64 that equal to 2 power 6. So 64 can be expressed as 2 power 6 multiplied by 5 power 0. Why? Because the denominator q should be expressed in the form 2 power n 5 power m. Denominator should be expressed in the form 2 power n 5 power m. So here n equal to 6, m equal to 0. That is, the power of 2 is 6, the power of 5 is 0. To get 10 power 6 in the denominator, 2 power 6 must be multiplied by 5 power 6. And hence, here 51 by 2 power 6 should be multiplied and divided by 5 power 6. So we have divided and multiplied by 5 power 6. There will be no change in the value. So after simplification, after this we get 0.796875, the decimal number. This is the answer for the problem. Now we consider another problem. And this is the fourth problem. 14 by 25. This is very simple problem. 14 divided by, this is 5 square. 25 can be expressed as 5 square. So 5 square equal to 2 power 0 multiplied by 5 power 2. Compare this with 2 power n, 5 power m. Here n equal to 0, m equal to 2. Now we want to get 10 square in the denominator. 10 square in the denominator. So 5 square must be multiplied by 2 square. 5 square must be multiplied by 2 square to get the form 10 square. So 14 by 5 square multiplied by 2 square divided by 2 square. Now students must understand why we have divided and multiplied by 2 square. This is because we want to get 10 square in the denominator. Why? We want to convert the given rational number into terminating decimal number. Because the denominator of the given rational number is of the form 2 power n, 5 power m. 2 power n, 5 power m. We must write all these theoretical steps. The denominator of this, the denominator to 25 is of the form 2 power n, 5 power m, where n equal to 0, m equal to 2. To get the form 10 square in the denominator, so we must write 5 square. 10 square equal to 5 square multiplied by 2 square. So therefore, we have multiplied and divided by 2 square here in this step. So this is equal to, we have to write all these steps, but I am not writing all the theoretical steps. I am simply explaining the steps. Students are advised to make running notes, and after the completion of the class, I will upload all the notes into resources of wiseapp. You need not worry. This is 14 multiplied by 4. 14 multiplied by 4 divided by 5 square multiplied by 2 square means it is 10 square. This is equal to 56 by 100 equal to 0.56. 0.56. Now, the next problem is the fifth problem. It is fifth problem. 80 divided by 100. Now we find prime factors for 80 and 100. For prime factors for 80, 2 40s, 2 20s, 2 10s, 2 5s, and 100. So 10 equal to 2 multiplied by 5. So 100 equal 10 square equal to 2 square multiplied by 5 square. So this is equal to 2 power 4 multiplied by 5 divided by 2 square multiplied by 5 square. So now from this step we get 2 power 4 divided by 2 square. We get 2 square in the numerator, and 5 divided by 5 square. We get 5 in the denominator. So now we write 5 equal to 2 power 0 multiplied by 5 power 1. So comparing with the 2 power n, 5 power m, here n equal to 0, m equal to 1. We want to get 10 in the denominator. We want to get 10 in the denominator. So to get 10 in the denominator, 5 must be multiplied by 2. 5 must be multiplied by 2. So to get 10 in the denominator, so here we have 5 in the denominator. We want to get 10 in the denominator. So this is equal to 2 square by 5 multiplied by 2 by 2. Why should we consider 2 by 2? Because we want to get 10 in the denominator. We want to get 10 in the denominator. This is equal to 8 by 10, that equal to 0.8. But students must understand that it is already in the form of 100 in the denominator. Why should we follow all this? We need not do all this procedure for this problem. Students must understand. Students must understand that we need not do this all this procedure for this problem. We can simply write 0.8, but we would like to apply theorem 1.4 to show that the denominator is of the form 2 power n 5 power m form. So 100 is there in the denominator. We want to show that it is of the form 2 power n 5 power m in the form. So we have shown like this. Instead of solving in this procedure, we can simply show in other way. Eighty by 100. 80 by 100 means we write 8 by 10. Again we can write 4 by 5. Without any calculations, we can write this. So now 5 is of the form 2 power 0, 5 power 1. So n equal to 0, m equal to 1. by comparing with the form 2 power n 5 power m. 2 power n 5 power m. So this is equal to 4 by 5 multiplied by 2 by 2. Why? Because 10 equal to 5 multiplied by 2. So this is here itself I got the form. I got 10, 8 by 10. I can write directly this is equal to 8 by 10 that equal to 0.8. I can say that directly here in this step only. But we must apply theorem 1.4 to show that the denominator is of the form 2 power n 5 power m. So we can simply without cancellation of this 80 by 100 equal to 8 by 10 that equal to 8 by 2 multiplied by 5 that equal to 0.8 we can say. So here we have not cancelled the number. Simply we have shown that the denominator is of the form 2 power n 5 power m. In this case 2 multiplied by 5 that equal to 10. So 2 power 1 multiplied by 5 power 1 form. So this is how students can solve the problem without any deviation from the procedure. We must show all steps and we must give the reasons. Now we have non-terminating recurring decimals in rational numbers. In rational numbers. So up to this, this is page number 11. This is page number 11. So to understand this concept, in the textbook 1 by 7 is considered. 1 by 7. So 1 by 7 is considered that equal to 0.142857 142857 142857 1 and so on. This is equal to 0.142857 bar. So you have already studied such type of decimal numbers, that is non-terminating recurring decimals in the previous classes. How to express these non-terminating recurring decimals in the form of P by Q. And here the observation is that the denominator 7 is not is not of the form 2 power n, 2 power n, 5 power m. It is not in this form. 7 is not in the form of 2 power n, 5 power m. So, when the denominator is not in the form of 2 power n, 5 power m, we get non-recurring terminating non-terminating recurring decimals in rational numbers. Now we consider different problems in this model. Do this problem. Do this. Do this. Page 11. Write the following rational numbers. Write the following rational numbers write the following rational numbers as decimal form and find out the block of repeating digits in the quotient. Here in the earlier problem, the block of 142857 is repeating in quotient. Actually, we should divide this and we have to show that 1 by 7 is equal to 0.142857, 142857, 142857 and so on. We have to divide it and we have to show this. And we have to finally write the block of repeating digits in the quotient. Now, in do this, we have the first problem 1 by 3. We have the first problem 1 by 3. This is equal to. So you must divide it 1.00000 like that. You have to take 3 is 0.3 910 3 10 3 910 3 910 like that. You must write here 0.3333 and so on. So what is block of digits? Block of digit 3 is repeating in a quotient. Is repeating in quotient. This can be expressed as 0.3 bar. So non-terminating recurring decimals can be expressed using a bar. 1 by 3 equal to 1 by 3 equal to 0.3333 and so on. So this is expressed as 0.3 bar. Actually we have to divide this and the block of digits actually here we have only 3. The block of digit 3 is repeating in quotient. So that's what we must conclude. And now we consider the next problem. Two by 7. The second problem is 2 by 7. Students, you must divide it by 7. 2.0000000 and so on. I can write 7 0.2. It is 1 4. So we got 6 0. So 8's 56. Again 4 0. 5's 35. Again 5 0. 7's 49. 1 0. 1's 7. So I get 3. So I write 4 here. 30 minus 28 by 2. So again here I get 2 is repeating. 2 is repeating here. Again I got the starting number. Here we have the starting number 2. So this block gets repeated. So 2 by 7 can be written as 2 by 7 is can be written as this is equal to 0.285714. Now you have to write that the block of digits 285714 is repeating in quotient. So I must keep a bar on this. I must keep a bar on this. So 2 by 7, 2 by 7 equal to 285714, 0.285 714, 714, and so on. This is equal to 0.285714 bar. So this is how the given rational number 2 by 7 is expressed as decimal number, that is non-terminating recurring decimal. Here what we should understand is that the denominator is there 7. 7 is not in the form of 2 power n 5 power m. 7 is not in the form of 2 power n and 5 power m. This is what you must understand. Even in the earlier example also, 3. So 3 is not in the form of, you must understand this. 3 is not in the form of 2 power n 5 power m. When the denominator is not in the form of 2 power n 5 power m, we get non-terminating recurring decimals. We get non-terminating recurring decimals. If the denominator is of the form 2 power n 5 power m, then we get terminating decimals. If the denominator is not in the form of 2 power n 5 power m, then such rational numbers will be the non-terminating recurring decimals. This is what you must understand. Now, I would like to give you 2 problems as exercise and you try to solve those 2 problems. I will give only 2 problems. Third problem, 5 by 11. And fourth problem is 10 by 13. You remember 11 is not in the form of 2 power n 5 power m, and 13 is also not in the form of 2 power n 5 power m form. So you do these 2 problems, you will get find convert into decimal numbers. Convert into decimal numbers. Dear students, I think you might have understood all the concepts which we have discussed so far. If you get any doubts in this chapter, you send your doubts to my email. The notes of today's class will be uploaded in wiseapp resources. All students can refer to the notes and you must try to understand the concepts. Thank you all students. Thank you very much.